Dear students, in previous video we have seen Lami's theorem. So according to Lami's theorem, each force is proportional to sine of angle between other two forces. So in this video I am going to cover numericals based on Lami's theorem, in which sphere is resting between two inclined planes. Okay. So the numerical is the 20 kg homogeneous smooth sphere rests on two inclines as shown in figure. Determine the contact forces at A and B. Now if you observe this figure, here the surface is making an angle of 75 degree and this surface is making an angle of 30 degree with horizontal. Now listen, the angle made by inclined plane with horizontal is equals to angle made by reaction with vertical. Now while drawing FBD, what we will do, for your understanding purpose I have drawn this separate sketch. Now look, there is self weight W. Now in this numerical they have provided us mass of sphere. There is no weight. So first of all we will convert this mass into weight. So W is mass into gravitational acceleration. So by using that formula we get W as 196.2 Newton. Now look, at point A we have to draw a line such that it must be perpendicular to this surface. Now I have drawn this line. Now if you observe, this line is making an angle of 90 degree with this inclined surface. So angle made by inclined plane with horizontal is equals to angle made by reaction with vertical. So if this angle is 75 degree, angle made by reaction with this vertical axis must be 75 degree. Similarly, if you observe this inclined plane is making angle of 30 degree with horizontal. So I will draw a line perpendicular to this inclined surface. So this angle is now 90 degree. Okay. Now angle made by inclined plane with horizontal is 30 degree. So angle made by reaction with vertical axis must be 30 degree. Now these two forces are push in nature. So while drawing FBD, I will convert these forces into pull type of forces. So it will be convenient for us. Now if you observe this FBD, now look, this is self weight, which is 196.2 Newton. Now this is reaction RA. Now we have seen this reaction was making an angle of 75 degree with vertical axis W. So if I extend this line, this angle will be now 75 degree. Similarly, RB is making an angle of 30 degree with vertical axis. So if I extend this RB line, it will make an angle of 30 degree. Now we have to just find angle between two different forces. Now look, the angle between W and RA. So this total angle is 180. So what I will do, 180 minus 75. So this will be 105 degree. The angle between RB and RA, this will be 30 plus 75. So this will be 105 degree. Angle between RB and W. Now look, this total angle is 180. So if I subtract this 30 from 180, this angle will be 150 degree. Now this is called free body diagram, where we have shown all active and reactive forces with their magnitudes as well as their natures. Now look, by using Lami's theorem. So according to Lami's theorem, each force is proportional to sine of angle between other two forces. So W divided by angle between remaining two forces is 105. So this will be W upon sine of 105 degree. Similarly, if you consider RA divided by sine of angle between other two forces, which is 150 degree, equals to RB upon sine of angle between other two forces is 105 degree. Okay. Now we got three terms. Now here we know value of W, which is 196.2 Newton, which is known force. Now all angles are known, one force is known. So we can calculate these remaining two values. So put value of W. So you will get this equation. Now consider this term as 1, 2, 3. By using calculators you can calculate answers directly, or if you don't know how to calculate it, using term 1 and 2. Now look, you have to go for cross multiplication. So 196.2 upon sine 105 equals to RA upon sine 150. Now RA will be sin 150 upon sin 105 into 196.2. So you will get RA as 101.56 Newton. Similarly, you can use first and third, or after getting RA, you can use second and third also. Now, after using first and third, 196.2 upon sin 105 equals to RB upon sin 105. Again, go for cross multiplication. From this, you will get RB as 196.2 Newton. Now, listen students. You can solve this numerical by resolving all forces or by using Lami's theorem also. Now here I have explained you two methods. So in first method we have solved this numerical by using Lami's theorem. Now we'll see how to solve this same numerical by using resolution method. Now look, consider same free body diagram. Now this RA is in first quadrant, so its x component will be plus, y component will be plus. If you consider RB, it is in second quadrant, so x component will be minus, y component will be plus. W is along negative y axis, so x component will be 0, whereas y component will be negative in nature. Now considering this system in equilibrium, and since forces are concurrent, we apply conditions of equilibrium. So there are two conditions of equilibrium for concurrent force system. So summation fx equals to 0. So plus RA cos 15 minus RB cos 60 equals to 0. So from this we will get one equation. Now apply second equilibrium condition, plus RA sin 15 plus RB sin 60 minus 196.2. So by solving this we will get second equation. Now you can solve this equation 1 and equation 2 simultaneously. By solving these two simultaneous equation, you will get RA and RB. Now if you observe these values are matching with previous answers. Now look, RA is 101.56 Newton. We have got same value over here. Now if you observe RB, it is 196.2 Newton, and by Lami's theorem also we have observed same value. So you can solve the same numerical by using two methods. Now we'll see second numerical. A cylinder of weight 300 Newton rests between the inclined planes as shown in figure. Determine the normal reaction at A and B. Now look, this sphere is resting such that one surface is inclined, making an angle of 30 degree with x-axis. But if you observe this second plane, it is making same angle 30 degree, but it is making that angle with respect to y-axis. So you have to take precaution while considering angles. So while drawing FBD, now look, since this surface is inclined, the reaction must be perpendicular to this surface. So this is the reaction. Now look, since this surface is making angle with respect to y-axis, reaction must make the same angle with respect to x-axis. So since this is 30 degree, angle made by reaction with horizontal axis must be 30 degree. Okay. Now consider the contact point B. Now this surface is making angle of 30 degree with respect to horizontal axis. So reaction at this contact point must make same angle with respect to y-axis. Okay. Now W is given to us, which is 300 Newton. Now we will draw simple sketch. Now all forces are meeting at this center point. So W is 300 Newton. Now convert this RA and RB into pull type of forces. So if I extend this RA to next quadrant, it will go to fourth quadrant. So RA, now since it was making angle of 30 degree with x-axis, this remaining angle will be 60 degree. Now if you consider this RB, which is now in fourth quadrant, will move to second quadrant. Now this RB was making angle of 30 degree with y-axis. So with respect to x-axis, this angle will be 60 degree. Now again we have to find angle between two forces. Now if you consider RA and W, so this angle is 60 degree. Now if you consider RB and RA, this will be 30 plus 90 plus 30. So this will be 150 degree. Now if you consider W and RB, Now this total angle from this to this will be 180. So 180 minus 30 will give you 150, or you can simply calculate 60 plus 90, which is 150. Now apply Lami's theorem. So look, 300 upon sine of 150 RA upon sine of 150 equals to RB upon sine of 60. So by using first, second and third term, you can solve this directly on calculator, or by going for cross multiplication as explained in previous problem, you can find RA and RB. So here RA comes 300 Newton and RB comes 519.615. Now this is the third numerical in which we have to find angle of tilt theta. Now look, numerical is find the angle of tilt theta with the horizontal so that the contact force at A and B, the contact force at B will be 1/2 of A for the smooth cylinder. Now look, we have to draw the sketch. Now look, this is the reaction RA. Now I will consider this as x-axis and this as y-axis. All forces are meeting at this common point. Listen, always for surface, for sphere resting in trough, there is push type of force acting on this sphere. Now look, since this angle is 45, so angle made by RA with respect to this x-axis will be 45 plus theta. We have to add this angle in this. Now if you consider RB, so this angle will be, since this angle is 45, so this will be 45 minus theta. So if you draw simple sketch where forces are meeting at one common point, this is the force W, which is self weight of sphere. Now I will extend this RA into next quadrant to make it pull by using principle of transmissibility of force. So this will be RA, angle is 45 plus theta. Similarly RB, angle is 45 minus theta. Now again calculate force angle between two forces. Now here our purpose is just to find angle theta. Now look, angle between W and RA will be, now this is 90 plus 45 plus theta. So this will become 135 plus theta, whereas angle at this for this force RB will be, RB and W will be 90 plus 45 minus theta. So this will be 90 plus 45 minus theta. So this will become 135 minus theta. And one condition is provided to us that reaction at point B is half of reaction at point A. So this will be half of RA. So this will be 0.5 times reaction at point. Now applying Lami's theorem, RA upon sine 135 minus theta equals to RB upon sine 135 plus theta. I have not considered term W because our purpose is just to find theta. But one condition is given to us that RB is 0.5 times RA. So just substitute RA upon sine 135 minus theta equals to RB will be 0.5 times RA upon sine 135 plus theta. Now RA from both sides will get cancelled. So our equation will reduce to sine 135 plus theta equals to 0.5 times sine 135 minus theta. So I have gone for cross multiplication. By using this you will get this equation. Now sine 135 plus theta equals to 0.5 sine 135 minus theta. Now here you have to go for trigonometry. So sine alpha plus beta equals to sine alpha into cos beta plus cos alpha into sine beta, whereas sine alpha minus beta equals to sine alpha into cos beta minus cos alpha into sine beta. Now in our case alpha is 135 whereas beta is theta. So by using this trigonometry equation, if you go on substituting these values, here you have to consider 0.5 on outer side of this value. Now by solving this you will get one equation in the form of cos theta and sin theta. So take cos theta terms on one side and sin theta terms on one side. Now here you will get two coefficients with cos theta and sin theta. So we want value of theta, so sin theta upon this cos theta equals to this value divided by this value. So your theta will be tan inverse of this ratio. So here you will get theta equals to 18.43 degree. Okay. So I hope you have understood numericals based on Lami's theorem, where we have applied this Lami's theorem to sphere resting in trough or channel. So you have to remember one thing, that whenever sphere is resting in trough or channel, the forces acting at contact point will be push in nature, because they will give compressive type of force on that sphere. So note down this. Thank you.